Hey class, Mr. Pusky here. Hope you're having a good day so far. We're moving on to 2.5 today, which is the name of the lesson is correlation and best fitting lines. Our essential questions are be able to determine positive, negative, or no correlation. Be able to approximate the equation of the best fitting line. Be able to draw a scatter plot given data. All right, so scatter plot is a graph used to determine whether there is a relationship between paired data. The graphs should have a positive correlation. A what? Positive correlation. A negative correlation. A what? Or relatively no correlation. Relatively no correlation. Okay? So, a positive correlation is basically going to be going up from left to right. And you can kind of see, we don't really have like a line like this where we can tell it's going up from left to right, but you can kind of tell by looking at this graph. What I like to do is I like to draw a circle, not really a circle, but like I like to trace around the outside of these data points to kind of get a sense of the trend. That's actually kind of bad. So you want to draw kind of you want to encompass around the outside of the data points, kind of like that, at the widest points. So the widest points probably these 2 points right here. So just make sure you encompass those widest points and then kind of keep it the same all the way out here. But this is called a positive correlation. Okay, because it's going up from left to right. As this thing increases, so does this y value increases. As the x value increases, so does the y value. Okay, so a positive correlation is going to be when the data looks like it's going kind of upward. Even though it's kind of scattered as a scatter plot, the trend is going upwards. Okay. And the way you can tell if it's a strong correlation is the skinnier that this circle that we drew is going to be. If it's like really skinny, if it's like this, that's like a super strong correlation. Whereas if it's like this, if it's like a circle, that is going to be like no correlation, okay? So down here we have this negative. This one's actually pretty skinny here. We're going to go like this. Okay, that's a pretty skinny oval we drew around there, right? This is called a negative correlation because as x increases, y decreases. Okay? So that's a negative correlation. Correlation just means how they relate to each other, okay? So if there's a strong correlation, they relate very heavily with each other and very directly. And if there's a negative correlation, they do not, or they do correlate directly, but it's just, correlation just, I'm mumbling over my words here. Correlation just means how these things relate to each other, okay? So there's a strong correlation, that means they relate very strongly with each other, okay? So for example, as the temperature increases, so does the amount of mosquito bites we have, right? Because temperature, when it's hotter outside, there's more mosquitoes outside, okay? For example, that's just an example that came off the top of my head here, but yeah. So anyways, sounds good. Or like, for example, the more that people ride the bus, the less cars are going to be on the road, right? Because more people are riding the bus. So that's kind of an example of both of those things. And then we also have relatively no correlation. So if I draw my oval around the outside of this, you can kind of see it's kind of a fat oval. This is going to be no correlation, or relatively no correlation. Okay, so they're not related. They're kind of random is what that means, all right? My stats professor in college, he kind of talked about the more that these look like cigars, which is kind of an old-timey reference, but I'm not encouraging smoking by any means, but the more it looks like a cigar, like the skinnier it is, or like a cigarette or something, or something else like that shape, he said the more it's going to be a strong correlation, and the more circular it is, this is more circular, the less the correlation there's going to be, okay? So, I gotta find a better example for that, but he was a, college professor, and he said the more it looks like a cigar, the more stronger the correlation's going to be. So if that helps you remember it, that is all good. Okay, just don't smoke. Smoking is not good. I'm not promoting smoking. Anyways, all right, approximate the best fitting lines. So we have this data here. So a best fit line is just to kind of like get a general sense of the trend for the data, right? So we can't really like tell what's happening with the data in terms of like projecting future data points and stuff if we don't have a line to work with, okay? So a best fitting line is all we're going to do is we're going to draw like an approximate line that fits the data nicely, and then we're going to come up with an equation to kind of help us figure out, what that's going to do, okay? So anyways, so we have these data points here. There's kind of a negative correlation here. Let me draw that again. Pretty skinny. Kind of a weak negative correlation, but what we're going to do is we're going to approximate a line that goes through the center of the data as best we can. It's approximate. It's not perfect, but you want to have the same amount of data above and below the... so, for example, if I draw kind of an approximate line here, you just want to draw a line between 2 points. That's actually kind of bad. Let me fix that. Yeah, it's still pretty bad. Sorry, it's kind of hard to draw on this iPad like this. I'm going to get it, I promise. That should be better. All right, that's a little bit better. Okay, so there's an approximation, all right? So one thing you need to be careful about is that you want to draw, you may or may not intersect any points, and that's okay, but you can kind of see that it kind of fits what's happening with the data pretty nicely. And also, if we have 1, 2, 3 points that are on the left or bottom side of the line, we should also have about 1, 2, 3, about the same amount of points on either side of the line, okay? So this is actually a pretty good line of best fit because it goes through 2 nice points that are kind of in the middle of all the data, and also there's an equal amount of points above and below the line. Okay, we're going to connect this. This is going to be the line we're going to use. And the reason we're making this line, we're going to write so we can write an equation and we can kind of like guess if this trend were to continue this direction or this direction, what would the new data points look like? Okay. So what we're going to do is we're going to pick 2 points that are really close to be on the line or really close above or below the line kind of thing. And so I'm probably going to pick these 2 points right here because they are right on the line that we drew. So that is the points are -3 and 2 and 1 and 0. All right. So we're going to find our slope. We're going to use point slope form to find the equation of a line. And that's what we're going to do. So let's do it. So we have m equals... So we have y2 minus y1 over x2 minus x1. So we're going to do 0 minus 2 over 1 plus 3. 1 minus -3, right? Slope formula. 0 minus 2 is -2 over 1 plus 3 is 4. That equals -1/2. So that's our slope. Okay. Now we're going to use point slope form. That is, we're going to do y minus y1. I'm going to use this one for x1 and y1. Okay, it's easier. Y minus 0, which is y minus y1. I'll write that out for you guys so you remember it. These formulas are going to be really important for you to remember, okay? Get in the habit. So we also are going to have m equals y2 minus y1 over x2 minus x1. Okay, those are the formulas that we're going to use for these kind of problems. Okay, so now we're plugging into this formula. We pick either point to be x1, y1 for this when we plug it into this equation. I just chose the one with 1 and 0 because 0 is an easy one to plug in. So we got -1/2 as our m times x minus, and then our x1 is 1. Okay, now we need to get y by itself. We need to distribute. So y minus 0 is just y equals -1/2 x plus, and then -1/2 times -1 is just 1/2. And you can kind of see that our b should be approximately 1/2 in the middle here on the graph. So there's our equation. So this is the equation that kind of matches the data nicely. And that's kind of why we were doing it, is to be able to figure out, if we wanted to kind of think about, the data with different data points that are not already given, this is how we kind of approximate it. Okay? All right, cool. And then over here, this is kind of a weak negative correlation. Okay, and then what you want to do is always draw that kind of oval around the outside of it. And this is kind of a circular oval, so it's going to be kind of a weak negative correlation. Even though it's still pretty, there's a trend. It's going downwards, and it's relatively grouped close together, but it's still a weak correlation because it's still pretty circular. If it were more like this, that would be a strong negative correlation. Okay, but it's not. It's kind of weak because it's kind of circular. All right, 2 more examples. All right, example 1, draw a scatter plot of the data, then approximate the best fitting line for the data. So we're going to graph all these points, and we're going to come up with an equation. And, it doesn't say to come up with an equation for both of these, but we're going to do it anyways because I feel like it's important to do. So just to get some practice. All right, so we're going to graph these points. So I'm going to go ahead and graph these points. So negative 4, 6 is left 4, up 6. You guys should know how to do this already. Negative 3, 4 is left 3, up 1, 2, 3, 4. Negative 2, 4.5 is left 2, up 1, 2, 3, 4.5. Negative 1.5 and 3 is negative 1.5 and 1, 2, 3. Negative 0.5 and 2 is negative a half and up 2. 0 and 3 is stay in the middle and go up 1, 2, 3. I'll pause here for a second here, make sure we're all caught up. Then we have 1 and 1.5, so we're going to go right 1, up 1.5. Then we have 2, 2, so we're going to go right 2, up 2. Then we have 2.5 and 0.5, so we're going to go right 2.5 and up 0.5. Wait, that's wrong. Is that right? I think I graphed that one wrong. 2.5, 1, 2.5, up 0.5. Yeah, I graphed it wrong on my sheet, but we're good. Then right 3, we got 3, 0. We're going to write 3 and stay on 0 here. Okay. All right, so approximate the best fitting line. So I'm going to kind of draw a line that's going to kind of encompass all this data and try to go, keep an even amount of points on either side of the line. So I'm going to go like this. I'm just going to turn my paper sideways and I just kind of like approximate a line. And this is kind of what I came up with here. That's actually probably not quite the best. Let me fix that a little bit. We need an even number of dots on either side. We'll see how that looks. So we got 1, 2, 3. 3 on one side. We got 1, 2, 3, 4 on this side, which is fine. This one's pretty close to the line here, so it's not a big deal. It's an approximation too, and the reason why I chose these, I kind of drew it this way, is I want to pick this point and this point because those are easier ones to plug into the equation, to find the slope and stuff here. All right, so it's a pretty decent approximation. But if you want to be more accurate, I'd probably go down here more and go like this, probably like something like that. But for now, I think that's pretty good. It's an approximation. So, those are 2 points we're going to use. We're going to use the points that is negative 4 and 6 and 3, 0. We're going to find the slope. So, m equals y2 minus y1. So, remember we got x1. I'm not going to do it. You guys should know that by now. Y2 minus y1. So, we have 0 minus 6 over x2 minus x1. 3 plus 4. We're going to get negative 6 over 7 is going to be our slope. I'm going to plug in this point because it's got a 0, and y minus 0 is pretty nice. Y minus 0 equals negative 6 over 7 times x minus 3. Okay, so we're plugging into point slope form to figure out the y-intercept. We have our slope, now we need our y-intercept. Okay. Then we're going to distribute. So we're going to get y equals negative 6 over 7x. Plus 18 over 7. Okay, I'm going to show you a trick here. We're going to go to a different app. So we're finish writing this down for a second. I'm going to show you how I got that number. I would highly encourage you to use a calculator and also use exact answers, which means using fractions, improper fractions, rather than decimals. So let's go to Desmos here. This is a scientific calculator that I would highly suggest you use. So what we're going to do is we're going to do negative 6 divided by 7. And I hit tapped over to the right a little bit. Then I'm going to do times negative 3. And over here, you can see to the right, I can't really circle it with this because it won't let me do anything. But you can see to the right, we have 2.571428571. That is an approximation. Okay, that probably goes on forever. And so what we want to do is hit the 2 boxes, the box over the other box like this, and it will give us an exact answer like that. Okay, so use this calculator, which you can download on your phone. You can have it on your iPad. You can have it. You can do it online. It's on. It's on our class page. It says Decimal Scientific Calculator, and you can also use the graphing calculator as well. But use exact answers, which we'll come back to in a little bit here. But our final answer is going to be y equals negative 6/7 x plus 18 over 7. I'm going to circle this really quick here. So use those 2 points, but we're going to circle to show the correlation. Okay, so that's a pretty strong negative correlation there. That's a strong negative correlation. It's got a pretty kind of tightly packed grouping. Looks kind of like a cigar, like we talked about. Again, not promoting smoking, just promoting what my stats professor said. That's what he suggests. So, yeah, if you guys come up with a different analogy or whatever, I'm open to hearing that. But yeah, that's what we got there. Okay, there's a strong negative correlation. Last example for today. So the table shows the number in thousands of black and white televisions sold in the United States from 1955 to 1995. All right. So first thing we're going to do here, we're going to graph these on a scatter plot. But what I would do is I would always call the original year, call that year 0. Okay, I'm going to put 0 right there, and then going up to 1960, it's going to be up 5. So 10, 15. Basically, they're going up by 5 years every year. Just do this. Makes it easier to graph. All right. It makes more sense, too. Okay, we go up to 40 there. All right. All right, we got to make our own graph now. Okay, so what we want to do, what do you think we're going to plot on the x-axis, which is our independent variable? Do years affect TVs, or do TVs affect the year? Well, what year it is going to impact how many TVs were sold, right? It's not going to be like, oh, I sold 5,709 TVs, so now it's year 1960. That wouldn't make sense, right? So down here we're going to have years. And we're going to go 0, 5, 10, 15, 20, 25, 30, 35, and 40. So those are all the different years that match with this data up here. Okay? Now we got to figure out a scale for the left-hand side. Our y-axis, this is y, this is x. So our y-axis looks like we're measuring TVs. So we want to start with the smallest data point that you see, and that's going to kind of smallest and tallest, and figure out like how many like boxes we need here. Well, our smallest one looks like it's 1,400. Our highest one is about under 9,000. So let's count how many boxes we have. So we can go by like 1,000. Then we got 2, 3, 4, 5, 6, 7, 8. That's pretty close. I'm going to go like this and call this 9 up here. Okay, I'm going to have to go a little bit farther above than what I wanted to, but that's okay. So that's a pretty good scale. So I'm going to fix those. So we have 1,000. We have, just scrolled on for accident there. 2,000, 3,000, 4,000. You don't want to use an actual scale that's the actual number on the data. That wouldn't make sense. You want to have an actual uniform or consistent scale going up and down by the same amount. Okay, so this is a good scale because it will allow us to graph points in between, 1,000 and 2,000 and all that stuff, and it will capture all the data. You want to go a little bit below the lowest data point and a little bit above the highest data points. All right, to kind of capture all the different things here. So we ran out a little bit of a room because we had to go up to 9,000, but that's not a problem. That'll work. All right, so let's graph these. We got 1955, our year 0 was 7,738. So we're going to go a little bit above halfway for 7,000. Then we got 5,709. We're going to go about a little bit above halfway. Between 5 and 6,000. All right. Then we have 8,753 for 10 years. That's going to be closer to 8,000 or closer to 9,000. That is. It's going to be up here. All right. 4,704. These are all pretty close, a little bit closer to the higher number, which will work. 4,955 for 20 is really close to 5,000. Then we have 1980 or 20 or 25 was 6684. So 6684. still a little bit above halfway. 3684, still closer to 4,000. 1411, so we're going to go a little bit underneath, between 1,000 and 2,000. And then 480, it's going to be about halfway, a little bit lower for year 40. Okay, so here is our data, and you can kind of see we have, I'm going to kind of go around to make our oval. Okay, that's not a great oval. Let me fix that. Let me try again. One more try. Oops. Okay, so there is kind of a correlation here. I would say that it's, and I think I could draw a better one, but I'm not going to try. It's kind of hard to draw on the iPad here, so just bear with me here. This is a negative correlation because it's not totally circular. This line should be a little bit closer to these points here, but it's kind of hard to do, so do your best. But this is going to be, it's a negative correlation, but kind of a weak one, but it still works. So we're going to draw lines now through the middle. So we're going to go like this. I'm going to go right through the middle. And we can see we have, dang it, right through the middle. Okay, this will kind of work. All right, so what we have here is the two data points I'm going to use probably. I think I'm going to use this one, and I'm going to use this one. Because if there's no point that goes directly, 2 points that go directly through the line, you want to pick one that's a little bit below the line and one that's a little bit above the line to kind of balance them out, to kind of get a better sense of the line here. Okay, you can also pick this one too, that's fine. Actually, we're going to stick with this one because that's what I did in my notes. But I just do the line a little bit sloppy here. But that's kind of a trick, okay? If you don't have 2 points that are exactly on the line, pick one that's a little bit below and one that's a little bit above, and that will kind of balance it out. But we're going to stick with these for now, and just keep in mind that, yeah. Anyways, so let's go ahead and do this. Let's pick these 2 points. We're going to come up with the equation for the line. So the equation of that line the points are 20 and 4,955 and 35 and 1,411. Those are the 2 points we're going to use. We're going to find the slope. M equals y2 minus y1, so 1411 minus, 4,955 over x2 minus x1 is 35 minus 20, which equals, so if we plugged into your calculator, I'm going to do that right now. I'm going to give you a second to write this down. I want to show you how we're going to do our scientific calculator now. Let's clear this. So we're going to do 1411 minus 4,955. Oops, let's actually fix that. Sorry, give me a second. So I'm going to do a fraction bar first. I'm going to do 1411 minus 4,955, and then click on the bottom. And I'm going to do 35 minus 20. Okay, so just get used to this calculator. It's going to be really useful. This is a fraction. The A over B is kind of a fraction button. Now we got our answer over here, which is negative 236.27. But we're going to click the boxes. That's going to give us our exact answer, which is negative 3,544 over 15. That's going to be our slope. So that's the slope we're going to use. Okay, that is the exact answer. That will reduce the fraction for you and come up with the exact answer that we want, which is more accurate than rounding of any kind. Okay, now we're going to plug into the slope point slope form. So we got y minus y1, so 1411. I'm going to use the second point, equals m, which is negative 3544 over 15 times x minus x1, which is 35. Distribute. So we get y minus 1411 equals negative 3544 over 15x. And now when we multiply those, it's going to be adding something. Let's go ahead and do that over here. So I'm going to click enter. I'm going to hit answer, the answer we just did. And I'm going to do times negative 35. Okay. And that's going to be our new answer. And click the little boxes again. We get 24,808 over 3. Okay? Just get the hang of this. I know it's kind of frustrating. This is kind of takes some practice, but this is going to give you exact answers, which are going to be you guys are eligible for 2 kids, so this is very important that you guys, know how to get exact answers. Okay? Then we're going to add 1411. So y is going to be equal to, we can put equal to, not approximately, but I'm going to take this answer, hit enter and hit the answer, and I'm going to add 1411. And then I hit the button again. Now I got 29041 over 3, which is going to be my new, so we got negative 3544 over 15x plus 29,041 over 3. Is that right? Did I get that right? I did. All right, cool. So that's the exact answer for the approximate line. Okay, so that's going to be a better, you could still use the, decimals or fractions or whatever, but if you start using a fraction up here, the farther along you go in the problem, the more inaccurate it's going to become because you're using approximations of approximations of approximations, okay? And so that's why I'm really encouraging you to make sure you use fractions and improper fractions because they will keep your answer more pure and more accurate, okay? So that's all we have for today. I think we covered everything. This is a weak negative correlation too, because it's kind of circular. It's not perfectly cigar shaped. So thank you guys for watching. I hope you guys have a great day, and we will talk soon.